Number 10 is 0. Number 12 is negative 1. Number...
That makes sense.
Good. Number 14 is negative 1. 16 is undefined. Number 18 is, we'll try without the screen. We're going to need it in a minute. But it is 30 degrees, and 210 degrees is an angle in the third quadrant, bottom left.
Does it want you to tell what quadrant?
It wants you to sketch the angle, and so that's I'm just describing the picture. If we need to see it specifically, then that's totally fine. We can do that in a second. But number 20 is pi over 3. And to draw it, you would draw an angle in the fourth quadrant, and then it would have a spiral going around once, and then all the way back around. So that's how you would draw that angle. Number 22 is 75 degrees, and to draw the angle, you would draw an angle in the fourth quadrant and go around clockwise.
Fourth quadrant, yes?
Yes. Mm-hmm. Number 24 would be pi over 6. And you would draw an angle in the first quadrant, and the spiral would go around and around, all the way around once, and then come through to the angle. 26 is square root of 3 over 3. 28 is negative 1. 30 is negative 2 times the square root of 3 over 3. 32 is negative square root of 3 over 2. 34 is, give me a second. The sine of theta is 1/2. The cosine of theta is negative square root of 3 over 2. The tangent of theta is negative square root of 3 over 3. The secant of theta is negative 2 times the square root of 3 over 3. And cotangent of theta is negative square root of 3. 36, the sine of theta is negative 5/13. The tangent of theta is 5/12. The cosecant of theta is negative 13/5. The secant of theta is negative 13/12. The cotangent of theta is 12/5. 38 is negative square root, sine of theta is negative square root of 2 over 2. Cosine of theta is negative square root of 2 over 2. Tangent of theta is 1. Cosecant of theta is negative square root of 2. And the secant of theta is negative square root of 2. 40, the sine of theta is square root of 3 over 2. The tangent of theta is negative 3, square root of 3. The cosecant of theta is 2 times the square root of 3 over 3. The secant of theta is negative 2. The cotangent of theta is negative square root of 3 over 3. 44 is negative square root.
42?
Number 42 is negative 6 square root of 3, 6, or negative 10.46, which in that particular problem, I would argue the second one is probably a better answer. Number 44 is negative square root of 2 over 2, and 46 is negative 1. 48 is negative square root of 3. 50 is undefined. Excuse me. 52 is 2. 54 is negative 2 times the square root of 3 over 3. 56 is square root of 2 over 2. 58 is negative square root of 3 over 2. What question on that lesson before we move to the next lesson?
Good Lord.
A lot. It might be more worth it to go into the next lesson.
And then just
And then
go back.
Okay, that's fine.
Unless I confuse you.
It will not confuse me. Thank you for thinking of me. What numbers do we do, 2 through 18?
Yeah.
Yeah.
Wait, what was this?
Huh?
That's fine.
Okay. Number 2 is right there. A little confusing to look at. They have the parent and the other in this context. The parent is the one with the greater amplitude. They've got arrows pointing to them. Okay. Number 4 is that one. Number 6. Whoop. Is right there. Not a period change. Did y'all know that y'all are my only class that doesn't have a test on Thursday? I guess so. That means y'all have to split the unit over Thanksgiving, so you're going to have to be vigilant to remember the stuff from before Thanksgiving, after Thanksgiving. But you got this. Number 8 is that guy. Got a period change again.
So, when did we learn this?
Well, if you watch the notes videos, then you would have learned it then. There were notes videos due yesterday.
Second video, too.
Oh, it's in the second video?
Yeah, because this is the second lesson. Did you not watch both of them?
I watched the full first one, but the second one was like 5 minutes, so I was like, and I didn't have time, so I was like, if I wasn't going to skip anything, this would be one to skip it.
Well, that was clearly a mistake. Number 10 has different possibilities, but that is one of them. I'll put 10 and 12 on there. They have different possibilities. You could, depending on how you're, these ones where they give you the picture and then you have to write, is that what it tells you? Oh, no, just kidding. What are these? Let's see. Where this 10 is, oh yeah. Yeah. Great. Number 14 is right there. Amplitude, period, frequency, phase shift, vertical shift, all the bits and bobs that are there. Use formulas to get. Number 16 is over here. Amplitude 1/4, period 2 pi, frequency 1/2 pi, phase shift 0, vertical shift of 3. And finally, number 18, amplitude 1, period 2 pi, frequency 1/2 pi, phase shift 3 pi over 2, and vertical shift -1. The one time I did this in college that was not in a math class, but in another class, the first thing we always did with these problems was remove the phase shift. Delete it out of the, not just delete it, but you gotta do a little math and get rid of it because they go on forever and ever and ever. So phase shift in most real world applications, well, I guess if you're comparing two signals, that are out of phase with one another, but very often a phase shift is pointless. Okay, so let's go back and take questions on the first of the two lessons, and we'll see where we go from there.
Start.
Okay, I'm not understanding, I suppose, how we're supposed to draw the triangles on the grid. Whenever we
Yes,
do the
me too.
angle thing.
Okay, so pick a number.
Wait, when do we do that? We do that. And do that in 26. Do we do that in 10?
On 26, you're supposed to find the exact value of the tangent of 7 pi over 6.
I think 32 somewhat.
32. Oh, I thought we fixed that, but we will fix it again. Here we go. So 32, we're supposed to find the exact values of the 5 remaining trig functions, and they tell us that the tangent of theta equals 2. Oh, just kidding. I'm looking at the wrong problem. Find the exact value of the sine of 300 degrees. Is that what you're saying?
Yeah.
Okay. Just kidding. This is not one that we fixed. This is a different one. Find the exact value of sine of 300 degrees. Okay. There's two things. One, because I didn't give you a me video, I gave you somebody else's video. First thing that I don't know whether he says or not is this thing. All students take calculus.
Yeah, he did.
Great.
I
Okay.
didn't understand it, but yeah, I did hear that.
Okay. So, where is 300 degrees?
In quadrant 3? 4.
Quadrant 4.
So it's going to be cosine of positive.
Yes. Which means our answer is going to be negative something, right?
Oh, okay.
And then we just need to figure out what the reference angle is.
The reference angle for 4 is
For 4?
for quadrant 4.
No. Reference angle for 300 degrees.
360 minus 300. Well, yeah, but the reference equation is 360 minus. That gets you 60.
Oh, like how, oh, I see. I see.
So the reference angle is 60 degrees.
60 degrees. So what's the sine of 60 degrees?
I don't know.
Work on memorizing the table.
When we're taking a quiz, we're not going to be able to use our tables or anything like that?
Yeah, that's right. If we take a quiz over it, you will not get to use any notes. That's correct. That's true. All you got to do is count to 4. 0, 1, 2, 3, 4. And then 4, 3, 2, 1, 0.
Right now we're using that table.
Yeah. 60 degrees is a what you call it? Special angle. All of these will be.
It's square root of 3 over 2.
It is. So the answer is negative square root of 3 over 2.
Okay, how do we do that table again?
You tell me. What do I write first? Which one goes on top, which one goes on bottom?
I don't know.
There's 2 trig functions. The third one takes care of itself. We don't care about that one yet. That's not really one we have to memorize. We really only have to memorize the top 2 rows.
Sine and cosine.
Sine and cosine, true. And then tangent would be down here. And then what angles are on the top? 0, which is 0 degrees.
30.
And then 30,
45.
which is how many radians?
Pi over 6.
Pi over 6, which is 30 degrees. And then True. This is the part where you just count to 4, right? So what's the sign of 0 degrees? 0. What's the sign of pi over 6? 1/2.
What's the radians of 90 degrees again?
Pi over 2. And what's the sign of pi over 4? Square root of 2 over 2. And square root of pi over 3? Square root of 3 over 2. Square root of pi over 2?
Square root of 1.
1. And then these just go the other way around, right? 1, square root of 3 over 2, square root of 2 over 2, 1/2, 0. And tangent is just sine over cosine, right? So you can fill that in. Okay, what other problems do we want to look at?
With that problem, I got the answer just by putting it in my calculator. Is that?
That would be wrong.
Okay.
So that would be right, but this problem will show up on a no calculator portion of the test, so that will not be an option. You need to be able to do it without. For now, while you're memorizing this, I would do it and say, this is what I think it is, and then you can check it on your calculator and then see whether you're right. And if not, go back and figure out what's going on with yourself, and then yeah, from there for there.
34.
34. We're supposed to find the exact value of 5 remaining trig functions of theta, and it's the cosecant of theta equals 2, where this is just like FYI kind of stuff, because this is basically saying it works. We're not trying to trick you. Is what these things are. Greater than 0, and the cosine. Well, it's also trying to tell us what range of values cosine of theta is less than 0. Kind of telling you in quadrant 1, basically, in standard form, and what we're saying. So, what now?
Quadrant 1.
This part.
But sine is associated with y and it's greater than 0, it's positive. And cosine is associated with x, and it's less than 0, it's a negative. So negative x and positive y is quadrant 2.
Oh, I just assumed it was telling us quadrant 1. I didn't actually check. You're probably right. Yeah, in fact, we should double check. I just assumed that was going to put it in standard form. I didn't think to check. I was going to get it wrong if I had done the homework. But let's see. So, where is sine positive?
The quadrant 2.
And 1, right?
2.
So it's up. And where is cosine negative?
2 and 3.
2 and 3. So we want the angles in this quadrant.
Cosine's x and sine's y.
Yes.
Yeah. Okay. Yeah. So we want the ones over here. So I like to draw our reference bit.
Okay, question. How do we know how to draw the triangle? Because I see it going down and to the right, and it's not consistent which way it's supposed to go, and I don't know what I'm supposed to be doing.
It is consistent. So it's quadrant 1, 2, it's here. If it's quadrant 3, it's there. If it's quadrant 4, it's here. If it's quadrant 3, it's there.
Would have been nice if somebody drawn that out at some point.
Now I did.
I thought it was supposed to be going clockwise or counterclockwise, like a pinwheel or something.
Well, so remember that it all goes back to a quadrant 1 something, right? And all we care about is it positive or negative, and we're talking about the x's and the y's. So, yeah, I mean that's kind of what's going on. So the cosecant is 2. What is cosecant?
2
1 over sine, so, and sine is what in x's and y's and r's? Y over r, right? So this would be r over y, yeah?
Yes.
Because cosecant is a reciprocal of sine.
2.
So this is 2, and this is 1.
Okay, so the radius of a triangle is the hypotenuse?
Yes.
Okay. 1 second.
So we can do a little math and figure out this part real quick. 1 squared plus x squared equals 2 squared, right? 1 plus x squared equals 4, x squared equals 3, x equals plus or minus square root of 3, absolute value is square root of 3, right? Looks like a 30, 60, 90 triangle to me.
Where's the absolute value come from? Is that just...
Just because we're doing distance. I'm just throwing that in there just so we remember all the bits. When we take the square root of both sides, we end up with plus or minus, but we're doing distance, so we throw out one of them. Yeah. So square root of 3. But actually, no, it's not even that's actually totally a lie. That's funny.
So then what don't...
How about negative square root of 3? Why is it negative square root of 3?
To the left.
Because it's to the left.
Okay.
Normally we would when we're doing just like right triangle trigonometry, but now we've got unit circle stuff, we've got negatives back. So we're talking about displacement instead of distance. Okay, great.
And then the theta we're trying to find would be
I don't think we actually need to find out the theta, we just need to know the trigonometric functions.
Well, you have to know where theta is, but by defining where the numbers are, we did that. You don't have to explicitly write it down, but yeah. So 1 over negative square root of 3 is negative square root of 3 over 3, right?
Yes.
And cosine.
I thought it was 1/2.
Oh, it is. My bad. Thank you, Aiden. Good catch. 1/2. And then adjacent over hypotenuse would be negative square root of 3 over 2. Tangent of theta is, this is 1 over negative square root of 3. So negative square root of 3 over 3. And then we already have cosecant, so the secant, excuse me, is negative 2 times the square root of 3 over 3. Don't just write that down. Make sure you know where it comes from.
Yeah. It's the opposite of...
It's this flipped over, rationalized, right? So 2 over the square root of 3, and then square root of 3 over square root of 3, and then 2, that.
So, opposite of
You have reciprocal.
reciprocal?
Yeah. Mm-hmm. And then the cotangent of theta would just be negative square root of 3.
Okay, I think I'm more understanding what I got wrong.
Good.
Okay. Sorry, I was trying to memorize things when you were talking about how you got 2 and 1 on the triangle.
I just know that.
It's just always 2 and 1. Just 2 on the hypotenuse, 1 on the opposite?
No, none of those words are right. Where did the numbers 2 and 1 come from in the original problem? This is the original problem, like that.
Oh, okay.
What is cosecant?
Cosecant is the reversed cosine.
Reciprocal of sine, s to c, c to s.
Oh.
It's reciprocal of sine. What is sine?
Sine is the
right, which is y over r, right?
Yeah.
Okay. So this would be r over y, right? R is the radius, yeah, the unit circle. Y is up and down. And then we use Pythagorean theorem to get square root of 3. And it's negative square root of 3 because we're in quadrant 2. And we know we're in quadrant 2 because of these things.
Understood.
Good. What other questions do we have?
42 word problems yet.
Coin funnel. A coin is dropped into a funnel where it spins in smaller circles until it drops into the bottom of the bank. The diameter of the first circle the coin makes is 24 centimeters before completing. Well, that picture doesn't have anything to do with this problem. Okay, continuing on. Coin makes 24 centimeters before completing one full circle. The coin travels 150 degrees and falls over. What is the new position of the coin relative to the center of the funnel? Great. A coin is dropped into a funnel where it spins in smaller circles until it drops to the bottom of the bank. This problem breaks physics, but it's fine. Because the coin would be traveling in a spiral, but that's fine. This problem is really stupid. But we can do the math that it clearly wants us to do anyway. Because I don't know if you've ever put a coin in one of those spinny things, but they don't go and then all of a sudden jump to. Okay, so let's give a little sketch of what's supposedly going on in this strange magical coin thing. Okay, so we've got a coin spinning in a circle, and the diameter of the first circle it makes is 24 centimeters. Great. And it goes 150 degrees. That would be in what quadrant?
2.
Quadrant 2. So it goes, right? 150 degrees. So, what is the new position of the coin relative to the center of the funnel? Great.
I do not know what it wants.
It's looking for this point right here.
It's looking for the coordinates of 150 degrees.
150 degrees over here.
Can you walk us through how to do that, please?
Yeah, you tell me.
Do not know. I genuinely
Yeah, you
don't.
know, stop, go back. Stop, go back. What things do we know? Let's start labeling different things different.
I know we use radius for something, so we know the radius is 12 centimeters.
We do. Great. Sounds good. So that would be the distance from here to there, right, is 12 centimeters. True facts. Great. What else could we discover? Yeah, it is a hypotenuse. That's true. Let's draw in our little triangle.
We have the adjacent, we have the angle thing, the 30 degrees.
It is 30 degrees. That's called a reference angle. That's the word you're looking for.
Why would the 12 centimeters be on the hypotenuse? Why isn't it on the x-axis?
Because it's the radius. It's not the x. It's not the x.
It's the radius of the circle.
It's the radius of the circle that the thing is traveling in. I broke my thing in the drawing. Yeah, it was the radius of this circle that's going around here.
Okay, that helps.
And we do know that the reference angle is 30 degrees. All that's true. Now what?
You can't really use the Pythagorean theorem, right? Because you can't do that because we only have one.
Do we have to fill in the other numbers based on that chart?
Hmm? This one's 6 centimeters. Where'd that come from?
Negative 1 side. So if we have a 36 to 90 hypotenuse divided by 2.
It is, because this is a 30, 60, 90 triangle, so this is the one side, and this is the 1x side, and that's the 2x side. So to get back to this one, we'll just divide by 2.
It's like the other.
Yeah, or you can just multiply 6 times the square root of 3. 6 times the square root of 3. But we want like something more reasonable, because this problem we want a decimal equivalent, because this is a word problem, right? So we already have a pretty number for the y part. So we know what we know right now is this is negative 6 times the square root of 3, 6, right? But let's get a decimal equivalent.
10.39.
Yeah. So negative 10.46.
Nice.
You say nice, but you understand where it all came from.
Yes.
Good. Then nice indeed.
Give me a second.
I'm giving you a second. Oh, second's over.
I need to
That was hilarious.
analyze. So reference angle, you got that by.
Also, you're supposed to label them as centimeters in the.
Yeah, you would. You're right. Totally true.
You don't understand the units in my house. You have to label them.
And that's the answer.
So as I was saying, reference angle, you would subtract.
Reference angle always goes back to the x-axis. So it's this one, or this one, or this one, or this one. Always. It always is the one between whatever it is and the x-axis. And we know this is 180 degrees. That's why we subtracted 150 from 180, because it's 150 minus the whatever this.
That's what I was looking for.
Yeah.
150 minus 150.
Yeah.
Oh, that makes more sense than what I was thinking.
Good. What other questions do we have?
48.
48.
Yes, that's a good idea. I like that idea.
Okay. We're supposed to find the exact value of the cotangent of 510 degrees. So much easier in radians, but it's fine, it's fine, it's fine. If undefined, right, undefined. So it's a great idea, even though it doesn't ask to do this, to get a little sketch of the thing.
Would this be a no calculator portion?
Absolutely.
But these whole.
Everything in this lesson would be in no calculator, except arguably like 42. But even that, even if I gave you something like 42, which I don't tend to give word problems in pre-cal tests, but that's not never, but that doesn't tend to happen. If I gave you one of 42, it would be on the no calculator portion, and I would tell you, leave your answer in exact terms. And then
So 510 minus 360 is 150. And then 150 is going to be in quadrant 2. We just did a problem with that.
That's the reference angle.
And then
well, the reference angle,
is
this
30 again.
is 150, but the reference angle is the one here. So 30 again, yes.
So then we have the same 1, 2, and then the square root of 3.
Cotangent is adjacent over opposite.
And this is just a normal 30-60 triangle.
It is.
If we're not, so like, if we're not given any like numbers for the sides of the triangle, then it's like the parent triangle.
I'm gonna try to answer what I think you're getting at, and we'll see whether I am or not. We know it's a 30, 60, 90 triangle because the reference angle is 30.
Yeah.
And so, yes.
Yeah, and like,
But it has nothing to do with the fact that we're not given numbers. If we were given any of the numbers, it would still be that. It would just be either the base one either stretched or compressed. Like it'd be dilated somewhere. But yeah.
Where did you get 6 1 from? I missed it.
Where did I get what from?
6 and 1.
6 and 1 is not written on the board. Where are you talking about?
How did you get the hypotenuse and the...
I didn't write anything about the hypotenuse because I don't care about the hypotenuse because I'm looking for cotangent. I wrote that the opposite is 1 and the adjacent is negative square root of 3. And cotangent is adjacent over opposite.
How did you find that one?
Because it's a 30, 60, 90 triangle. The small leg is 1. The hypotenuse is 2. Yeah, that's why they're special right triangles, because they're always the same. Well, they're special right triangles because, in this case, because equilateral triangles. So.
And then,
Yes.
did you do pi tag in your head to get -3?
That's all okay. Mita. No. Yeah, like a week and a half, but it's fine. We'll get you caught up, hopefully. What kind of triangle is that?
I don't know what you're asking me to do.
I'm asking you what kind of triangle is that? So I haven't asked you to do anything yet.
Right triangle.
Yeah, it's more specific than that.
30, 60, 90? Is that yours?
This one? Definitely not. This one is. What kind of triangle is that?
Equilateral triangle. No, it's not.
What is pi over 4 in degrees?
I've yet to memorize that.
What's pi in degrees?
1 pi?
Yeah,
That's 180.
great. So half of that. Half of that, yeah. So what is it?
45?
There you go. Look at you. You memorize it. You see, you don't have to. That's what I'm saying. Like this whole way. Like you don't have to memorize everything. You can memorize bits and then get the rest of the way there with just a little bit of arithmetic. That's 45, 45, 90 triangle. What are the ratios on a 45, 45, 90 triangle? Always.
I don't remember. I don't.
Always. 1, 1, square root of 2. 1, 2, square root of 3. Always. Always and forever, every time.
Oh, and so you just said, oh, that's the square root of 3 and it's negative because it's in the second quadrant.
True. All that's true. Yes. Great. Grand, glorious. What other questions do we have?
Can we go back to
We
calculus?
calculus? You're not ready for that yet.
Can we go back to algebra then?
No.
Anything that has to do with geometry sucks.
This doesn't have to do with geometry. It has to do with trigonometry, which is clearly different. We may want to look at some graphing. Do we have questions on that lesson?
Actually, no, I somehow.
Okay, you don't. Does anybody else have questions on graphing? We know why you have questions, but does anybody else have questions? You have the same reason as him?
Yes.
Okay, well, there you go.
Thank you.
You understand the graphing, Aiden? Okay, back to 4-3 then. Any other questions on 4-3?
Do you usually explain? Wait.
How do you know on the triangle which one is
sine and which one's cosine? Like, is the hypotenuse always?
Sine is opposite over hypotenuse,
Oh,
which is y over r.
How do you know whether they're negative or positive on the triangle?
Which quadrant they're in, and all students take calculus. Both of those two.
we do 12.
In a second, yeah.
And so all students take calculus, but how do you know if like the square root of 3 is sine or cosine?
Square root of 3 in that example was x. So cosine is x over r. Does that make sense? Good. 12. That's true enough. It's true enough. So we're supposed to find the exact value of the cosecant of 270.
I was confused because this one's.
Where is it?
It's right down, straight down.
What is cosecant?
It's the opposite of.
No, the reciprocal, but keep going.
Reciprocal of the
S to C, C to S.
Okay.
So which one?
It's the sine.
There you go. That's 1 over sine. What's the sine of 270 degrees? What is sine in x's, r's, and y's?
It's gonna be 0? No, it's gonna be undefined, because it's 1 over 0.
See, that's a.
Okay, stop, hold on, go back. Cosecant. What is sine? What is sine in x's, r's, and y's?
Y.
R, no, y over r.
Y over r.
Why over R is confusing.
R is always 1, always.
Okay.
Unless we're doing a problem where like it gives us, but like in the unit circle, R is 1. That's the whole point of the unit circle. R, like we're doing it with a circle of 1, right? So what is the sine of 270 degrees? Down 1 over 1. So what's the sine of 270 degrees? Negative 1. And then what's 1 over negative 1? Negative 1. Cosecant of 270 degrees is negative 1.
Okay, well then the chart, I'm not understanding the chart thing.
So we always have a radius of 1 unless it's said that it's something.
The sine of 90 is 1. The sine of 0 is 0.
What about the sine of 180?
Sine of 180 would be 0 as well.
Okay, so the x-axis is 0 and the y.
So here's and this will make more sense once we get the next lesson and we get all the graphs. It'll be even clearer, but it's worth noting that sine and cosine are never undefined. And you remember, so on the graph, it keeps going forever and ever and ever and ever and ever. So there's no point at which they're undefined. Now when you see in the next lesson, and we start graphing tangent and it's got asymptotes, and cosecant and secant that also have asymptotes, they have points at which they're undefined. But sine and cosine are never undefined for all values in there.
Okay.
With the, I have a question over the notes. With, we made a new circle in the videos where we also drew down the coordinates of every angle.
Mm-hmm.
Should we memorize the coordinates of every angle?
Well, you kind of already have, kind of. It goes back to the chart. right? Because they all go with those special triangles.
No, the 30 degree and the 60.
It's 30, 60, 90, 45, all those. Yeah. Yeah. So if you want to, so whichever way is easier for you to memorize it, I think the chart is easier to memorize than trying to remember the whole unit circle in that way.
And then with the chart, we would just plug it in as cos being the x value and sine being the y value of the coordinate.
Well, sine is x over r, which if we're just talking about just pure values without other stuff, without specific triangles, then r is 1 always, right? But yeah. Yeah.
Yeah, sure.
So I'll do something over r.
Yeah, so sine is y over r, cosine is x over r, tangent is y over x, etc. Any other questions for you that we can look at in the last couple of 10 minutes?
Trying to remember how to do this.
What is tangent?
Tangent is either x or opposite
Mm-hmm.
or something.
Yeah, so where is 2 pi?
360 or
Right here, yeah. So y is 0 and r is 1, so it's 0.
When do we know when to use 0 and 360 on like a circle?
They're the same. The sine of 0 is the same as the sine of 360 degrees. It's the same, so it's irrelevant. It's also the same as 720 degrees,
Yay.
et cetera, et cetera, et cetera. What is it, 1544, is that right? I feel like that's right.
This doesn't look right. Is that correct?
Just the table part?
Yeah, just memorizing.
Yeah. 0, 1/2, square root 2 over 2, square root 3 over 2, and 1. 1 and square root 2 over 2, 1, 0, and 0, and square root 3 over 3, and 1, and square root 3, and undefined. That is absolutely correct. Now you gotta rememberize it and practice using it. And we'll be close to the right thing.
So
All right.
that's something we need to memorize.
That-
Tangent